Question number 1. The given the velocity is the engine performance. Cubic capacity is 250 cc. Over square ratio is 1.2. This is the diameter to stroke ratio, stroke length ratio. And due to the stroke length ratio diameter to L, d by L equal to 1.2. Therefore, we arrange this equation L equal to d by 1.2. Now the clearance volume is given 28.5 cc. Find out the compression ratio RC of the engine, diameter of the bore and length of the stroke. Now we apply the value of the swept volume. We know that the swept volume equal to pi beta 4 d square L. This is the area and stroke length L. Then we put the value as well, the 250 cc, and pi beta 4 d square into L is replaced. This is the ratio of the diameter to stroke length. This value is d by L equal to 1.2. Now the replace the value is L equal to d by 1.2. Therefore, L value is here pi beta 4 d square into d divide 1.2. Rearranging the equation, and dq equal to 382, and therefore d equal to 382 whole power 1 by 3. Now the root 3 root under 382 cubic square cube and cube 382 to the power 1 by 3. This is a cube root. This value is 7.26. We consider 7.3. Then again, stroke length L equal to, taken the value is here, L equal to d by 1.2. Now the value is 1.2. 7.3 divide 1.2. 12 multiply 6, this is the 7.2, and this value is 6.1, 7.3. Then the 12 divided by 7.3 is approximate value is 6.1 cm. Therefore, we get the diameter of the bore is 7.3 cm and the stroke length is 6.1 cm. Now we solve the question number 3 in question 1. Find out the compression ratio. We know that the compression ratio is the total volume divided clearance volume. Therefore, in a PVTS diagram, we see that from on the vertical line, pressure line, and the horizontal line is the volume line. Now from the vertical line to the vertical dotted line VC at light V2, this is the clearance volume, and from V2 to V1, this is swept volume. Now the total volume is the clearance volume plus swept volume divide clearance volume. This is the ratio is compression ratio. Now we put the value. Swept volume is 250 cc plus 28.5 clearance volume. Divide the clearance volume value. Summation of this 278.5 divide 28.5. Now the value is 9.77. Round up the value we have taken. Compression ratio equal to 10. Question number 2 for engine performance. In question given, the mechanical efficiency of the engine is 85%. Here eta m equal to 0.85, and the frictional power is given 30 kilowatt. And for a single cylinder engine, we find out the brake power and indicated power of the engine. mechanical efficiency equal to brake power divide indicated power, and here given the mechanical efficiency 85%. Also we know that the indicated power equal to brake power plus frictional power. Find out the frictional power. Then Fp equal to Ip minus Bp. We put the value of the mechanical efficiency eta m equal to Bp by Ip. Ip equal to Bp plus Fp is here. Therefore we calculate the equation. And we get the result of the brake power is 166.67 kilowatt. Next, find out the indicated power, which is equal to brake power plus frictional power. Indicated power equal to 167.67 kilowatt plus frictional power 30 kilowatt, and we get the result indicated power 196.67 kilowatt. Question number 3. Engine having capacity of the load delivered 42.5 kilowatt engine, and the mechanical efficiency is given 85 kilowatt. Find out the indicated power and brake power. Engine load means the brake power of the engine, i.e. the load at which the engine can deliver. This value is 42.5 kilowatt, and we apply the mechanical efficiency. Then Bp by Ip, rearranging the equation, Bp divide eta m mechanical efficiency, and we put the values, and Ip is 50 kilowatt. Now we find the frictional power, Fp equal to Ip minus Bp, then 50 minus 42.5, 7.5 kilowatt. And the condition 2 in equation say that frictional power is constant, and find out the mechanical efficiency if the load is 60%. Therefore the load is 60% means the brake power of the engine in load is only 60%. Therefore now the next we recalculate the equation. Bp equal to brake power equal to 25.5, which is the 60% of the earlier brake power, and find out the Ip. Then adding the brake power plus frictional power, we get 33 kilowatt, and we find out the new mechanical efficiency eta m equal to Bp by Ip. This value is 77.3%. Question number 4. The data is given. The engine having 4 cylinders, therefore K value is 4. The engine developed the brake power is 50 kilowatt. Air fuel ratio 9:1. Calorific value of fuel 34 megajoule per meter cube. 34000 kilojoule per meter cube. Compression ratio 10:1. Volumeric efficiency is 70%. Indicated efficiency 35%, mechanical efficiency 80%, and the total volume is 2 liter. Now find out the engine speed, n equal to what? First calculate the total volume per cylinder. Now the total volume is given is 2 liters, and we know that the 1 liter equal to 1000 cc. Cc means cubic centimeter. Therefore, total volume per cylinder, here 4 cylinders divided by 4, then 2000 cc divided by 4 equal to 500 cc. Therefore, the intake of the air inside of the cylinder, each cylinder is 500 cc. Now the swept volume per cylinder, we calculate the swept volume per cylinder is what? And Vs equal to 9 by 10 V total, and 9 by 10 V total in from what it comes. Now first we put the value of the compression ratio, which is known as the total volume divided swept volume. Then again the rearranging the equation, and we find out Vs equal to 9 by 10 V total, and Vc equal to 1 by 9 Vs. Put the value Vs equal to 9 by 10 V total. This value is 450 cc, cubic centimeter, and the clearance volume is 50 cc. Therefore, total volume is 500 cc. We noted the volumeric efficiency equal to volume of air taken inside of the per cylinder divided displacement volume, which is the swept volume, Vs. Now we find out the volume of air in per cylinder equal to volumeric efficiency multiplied displacement volume. This value is 315 cc. Now we find out the volume of the gas inserted inside of the cylinder in per cycle. Therefore, the ratio is given air fuel ratio 9:1. Now we calculate the air to fuel ratio. Fuel is inserting inside of cylinder as a ratio of the air ratio divided 9. Therefore, the value is put in here. The air volume divide 9, air volume per cylinder we have earlier calculated 315 cc. Now the each cylinder of the gas is inserted inside of cylinder is 35 cc. Converted into the meter cube, 35 into 10 to the minus 6 meter cube. We calculated the value of the energy supplied per cylinder, E equal to calorific value Cv, which is given in megajoule per meter cube. Now here we multiply the volume of gas inserted per cylinder in meter cube. Therefore, the result of the energy supplied E in kilojoule, 1.19 kilojoule. In per cylinder of the energy is 1.19 kilojoule. Find out the indicated power. We apply the indicated thermal efficiency ITH equal to indicated power divide energy supplied per cylinder per second, which is the calorific value. We find out the per cylinder energy supplied equal to IP divide eta ITH and divide 4, because here 4 cylinders are here. Therefore, per cylinder energy supplied then divided by 4. IP equal to BP divide mechanical efficiency. We put 50 divide 0.8, and the new energy supplied per cylinder per second value is 44.64 kilojoule. Earlier we find out the E value is equal to 1.19 kilojoule and E1 is equal to 44.64 kilojoule. Energy supplied per cylinder per second. E1 divide N divide 120 here. The 4-stroke engine is consideration. Therefore, N by 2 here power stroke is half of the over full cycle. Therefore, N by 2 into 60. Here N by 120. E1 divide N divide 120 and rearranging the equation and equating the equation 1 and 2. Here the equation 2 and the equation 1 value is E equal to 1.19 kilojoule. Therefore, find out the N, the revolution per minute, RPM equal to 4.4501 RPM. Thank you.